Hello, and welcome to today's webinar, Practical Tips for Reducing Cost and Complexity of High-Precision RTK Solutions, brought to you by GPS World Magazine and our sponsor of the event, u-blox. I'm Hallie Reed from North Coast Media, Content Marketing Manager for GPS World Magazine, and I will be your event manager for today's presentation. At this time, I'd like to get you comfortable with our council and the ways that you can participate in today's presentation. Please notice the Q&A panel on the left-hand side of your console. If you have a question, type it in the panel's text box and then click Submit to place your question in queue. You may also use the hashtag GPSWebinar on Twitter to submit questions during today's webinar or to enter into discussions with other attendees. We encourage you to ask and enter any questions you may have for our speakers during the presentation. We will address these questions at the end of the presentation during the Q&A portion. Questions submitted during registration have already gone to our speaker and may be covered during the presentation. If you have any technical difficulties today during the event, you may use the same Q&A panel on your screen to submit your issue, and technical support specialist Jesse or I will personally assist you. Finally, you may learn more about today's speakers by viewing their photo, bio, and contact information in the panel located in the upper left-hand corner of your console. Now I'd like to introduce today's speakers. Today we will be hearing from Armin. Armin is a seasoned expert in GNSS high precision positioning with years of experience immersed in the field of design and production for mobile robotic and precision agricultural applications. Armin specializes in satellite navigation and positioning as a geodesist from the Technical University of Berlin. Currently, he focuses on facilitating the journey for industrial applications EMEA region as segment manager at u-blox. Armin is based in Berlin, Germany. We will also hear from Joseph. Joe is one of Calian's field application engineers with an RF and antenna design background involved in the research and development of Calian's highly performing and state-of-the-art GNSS antenna, most notably the helical antenna line. Joe has a Master of Applied Science degree in electrical engineering, along with a Bachelor of Engineering degree in engineering physics. While he is not tucked away in the lab or in a meeting with Calian's clients, Joe enjoys spending time exploring the wilderness of Canada and photographing birds and wildlife. At this time, I'll turn the presentation over to Armin. Take it away, Armin.
Hey, thanks, Holly. Thanks a lot. Hello, everyone. Glad to be here with you, and I want to appreciate the GPS Board to give us this chance regarding this webinar. Without any further delay, let's jump through the topics that we have today. So we're going to hear together a little bit about the complexity of high-precision GNSS and RTK technology, and also understanding a little bit, let's say, the hidden challenges beside the service delivery, and what are the, let's say, the points that you as a product owner, you need to keep that in mind about the price performance, let's say, topics. And also what type of prototyping you can use for your product, which is going to be easy, straightforward, without any kind of challenges. We will go to a few study cases, let's say the real scenarios from various customers, and also taking a look how the GNSS is going to shape the future of some of the projects in the upcoming time. So keep that in mind. We have some small pro tips in the slide. It might be helpful for you. So at the beginning, let's see what is happening in case of the, let's say, this technology, and also how is the acceptance of the market about that. I think many of you are informed about it, and you're also dealing with this type of topic. The GNSS technology and also high precision positioning specifically, not only standard positioning, but high precision positioning, is getting widespread into different type of application, traditional type of application, which it was in this market for a really long time, but also in emerging type of applications, some prosumer, consumer type of application, which actually in the past it was not possible to use GNSS RTK technology for that. But right now, thanks to all the, let's say, advancement in case of the hardwares, and also development of the different type of constellation of the GNSS, it's possible. We shouldn't also ignore all the innovation which has happened in case of, let's say, the antenna, which is amazingly important, beside also the correction services. When we're talking about GNSS device, we should think about that right now. In the past, for example, that was a surveying type of application. So you didn't have any kind of problem with the size. Of course, it's a matter always, but it's not like an IoT application. So power consumption, performance is going to be also the same thing. There's a matter of reliability, which is also important. And of course, big topic, cost needs to be really adapted to this type of application. And all this advancement catalyzing, let's say, providing this type of technology to the mass market. When we're talking about, let's say, emerging application or traditional application, we can also name a few of them here. Some of them is like ground robotic type of application. As an example, we can mention delivery robots, which they're getting benefit of different type of technology. One of them, which is they are relying on that, actually, it's, let's say, GNSS RTK. And also another one in the consumer type of application, for example, we can mention robotic lawnmowers. And UAVs, of course, specifically those ones that they are going to get benefit of navigation in real time with the RTK. They are getting use of this type of, let's say, technology and data. Precision agriculture, they have a long tail and long history in case of using the RTK technology, but it's getting more even widespread. Different type of platforms are coming and used using this, let's say, system. Heavy machinery is the same. Of course, another one which has a really important, let's say, footstep is autonomous car driving systems. And it has really critical points. The future is going to be part of daily life, but it's there's a lot of steps to reach to that. And one of the things which is greatly helping that is the GNSS, either in case of the safe or non-safe type of application in autonomous car driving. Another example, which is really tangible for many of people, is actually micromobility, like the scooters. You see that all around the cities, but sometimes it's getting messy in the cities because the parking slot for them is not, let's say, properly placed, or the people, they're not parking that in the right place. And GNSS technology is helping to navigate in the right place, to drive in the right place, and park in the right place. Let's see some of the challenges together. So of course, as a product owner, you want to have a product which has enough accuracy for your application, but you don't want to change your major from electronic engineer, IoT developer, to be GNSS expert. So you want to have a, let's say, limited effort for that. And GNSS system sometimes has a really high complexity. So in that case, you want to have a, let's say, an easy to go solution, which has also a high reliability. Reliability is an issue. It was an issue mainly for a lot of applications, specifically when you're using the RTK technology. If you wanted to use different type of services, in the past, many of the services were so fragmented. So as an OEM, you cannot produce your product provided to the market, and let's hope that it falls into the right place. So you want to have really a reliable solution which is working everywhere. And also the additional cost which this type of solution will bring, like data cost, RTK subscription, and so on. And what should you consider? What is important actually to overcome those challenges is to select the right GNSS receiver, select the right correction services, and also the right connectivity. The income of all the signals, everything is placed inside of the antenna. So antenna is really important. And when you have all of them, what is important is actually, again, the cost, either ongoing or the BOM cost of the material. So both in another representation, the CapEx and OpEx have to be really well defined. Just a quick tip in this scale, of course, you want to have the best accuracy with the lowest cost. But it's really important to understand how much, let's say, accuracy you can sacrifice to achieve a better cost. Sometimes you can have a really unique implementation with a really high cost, but if you step one below, your accuracy is going to be a little bit maybe tackled, but your cost is going to have a big jump. So that's really important to have this type of, let's say, assessment before going to choose these items. And also it's really important when you're talking about accuracy, you understand that for your application specifically, you need absolute accuracy, you need relative accuracy, what type of, let's say, parameter is really important for your application. Let's make a kind of examples from a real, let's say, application scenario. So one of the customers, we had the chance to collaborate with them, 01 Labs, and they are providing rigidized auto guidance for agricultural application. And the challenges that they had is actually there was a lot of complexity in front of their way. Support is a matter because, of course, there is a limited capacity for everyone to provide, let's say, support. And if the problem is getting really complex, sometimes this is going to lead to a massive learning curve. And that means cost, that means spending resources. So you should really be careful about this one. And also another challenge is that they wanted to provide their solution with the RTK subscription, and that was a challenge for them because the cost was really high and the unlocking key, hidden, let's say, type of keys sometimes is a little bit painful. Let's jump into that. Keep that in mind, those items that we mentioned, GNSS hardware, correction services, antenna, and so on. Let's tackle one by one together. So when you're going to choose your GNSS hardware, there's a lot of options coming in front of you. Single band, dual band, triple band, L1, L2, L5, which one you have to choose. So when you're talking about, let's say, under 1 meter type of application, when you're talking about few decimeter and centimeter, all of them, you need to have a kind of correction services plus a dual band. You can, of course, with the single frequency, you can also reach together with RTK, you can reach to good accuracy in case of decimeter, but it's a matter of reliability. If there is a little bit disruption in case of the sky plot that you have, then it's going to be difficult because you lose your accuracy. But dual band is going to bring a lot of, let's say, capacity in case of the reliability for you. And together with the RTK, you can easily reach to centimeter level of accuracy. But without RTK, you're going to have the accuracy more than 1 meter. So whenever you're thinking about less than 1 meter, half a meter, 30 centimeter, or 10 centimeter, you need to have some kind of correction. But which correction, which is be affordable for your type of application, this is something that you're going to talk about. And also another option is L1, L2, or L1, L5. What kind of option is good? So what is important really for the RTK is the number of the satellites in the sky plot. And until today, L1, L2, you see more number of the satellite in the sky. And that's the reason that when you're going to have, let's say, application which wants to use an RTK solution, our recommendation to you is that to use L1, L2 option for the time being. L5, of course, is a newer, let's say, technology. Specifically, you're talking about the GPS constellation. It's a newer type of the signal. It has a better, let's say, multi-path mitigation. Let's say, it has a low RF interferences, and it's better act in case of urban area. But still, this signal is tagged by the GPS constellation as unhealthy. So if something happens for the constellation, you don't realize that because it's already tagged as an unhealthy. And also the number of satellites is not completed. Of course, in the future, it's going to be completed. Right now, it's not in place. So for the time being, our recommendation is that if you want to have, let's say, dual band standard precision, when I'm saying standard precision means around more than 1 to 2 meter accuracy, L1, L5 is an amazing solution. But if you're thinking about RTK type of application, it's much better if you're stepping into the L1, L2. And beside of that, there is also other type of sensors that you can combine it together with your RTK. RTK is not the only, let's say, solution that you can get benefit of that, but you can also combine that with the accelerometer, gyro, wheel-tick, which in case that you're losing your, let's say, RTK signal, in that case you can rely on the other sensors until you come back live, until your GNSS, let's say, it's going to have a visibility to the sky. And this is something which is also recommended for many applications. And we try to provide that also for our customers in our portfolio. One part of the, let's say, the families of the product that we're providing is the F9 family. So in this family, we have the ZF9P, which is providing high precision, multi-constellation, really enhanced and, let's say, with amazing size and power consumption. Also, we have a variant of ZF9R, which has a dead reckoning functionality inside. And that's also fantastic for various type of application. Keep that in mind. When you have the sensor fusion, you also need to think about the dynamic model, what type of application is going to be placed. This module is going to be placed inside of that. And we invested a lot of, let's say, R&D into that to model different type of application, including, for example, slow-moving vehicles, or bike, or let's say agricultural machinery, and so on. And also we have a new F9P, which is a really small one, L1, L5, and that's also an amazing solution. And it has also the capability of the RTK, but if you want to use it without RTK, you're going to have a fantastic result. Coming to the correction topic, which can be a little bit more complex. But at the first, let's look at what is correction, what should we correct, what type of error we want to correct in another sense. So in general, when we are talking about, let's say, observation in case of the GNSS, we have a few type of error which is really important. 3 of them is actually coming from the satellite orbit error, clock error, and the biases of the satellite. And the most important one, which is affected on the signal, is the ionosphere and afterward troposphere. So these are the 5 global, let's say, range of the errors, which when we're talking about the corrections, actually corrections are going to help you to actually have a better estimation of these errors, the global errors. But there are also some environmental, some local errors like multipath, and also the receiver noise and so on, which the antennas, for example, is going to be really helpful in case of the multipath. That's really important. Also, where do you place that? What type of antenna you're using? Considering these 5 global errors, different type of the correction services are providing them in a different way. When we're talking about RTK correction service, RTK is providing one value, and it's a combination of all these errors together. Another type of service, it's PPP, which is only providing 3 of them. That's satellite orbit, clock, and biases. And another one, PPP RTK, which is, we can say it's a kind of combination of both PPP and RTK in various sense. Is providing also high resolution atmospheric and also tropospheric method. What are the differences between them? Which one is actually suitable for what application? We're going to also talk about that. But just keep that in mind. When you have high multipath, also you're going to increase the initialization time when you're moving from the RTK to the others. And also, let's say the accuracy in general, in case of the RTK, is the highest one. But PPP RTK has different type of advantages that we are going to see in the next few slides. So if we consider that for the RTK, you have 2 different options. You can use one single base station somewhere, or you can use a network RTK. And both of them is a valuable option. But keep that in mind, in case of the single base, you are going to cover a radius of 10, 20, 30 kilometers. If you have a dynamic application, like imagine you have a UAV which is flying from one side to another side for kilometers, you cannot use a single base RTK. You want to use network RTK, usually the coverage is regional, And also there's a high data bandwidth associated with them. It has the best performance, but it has a high cost and has a high complexity. PPP-RTK, usually it's, let's say, for example, when I'm talking about PPP-RTK, I specifically pointed out the services that we are providing as a PPP-RTK. It has a different level of the accuracy. So theoretically, they're measuring the RTK is around 1 to 3 centimeter of accuracy, but PPP-RTK is around 3 to 6 centimeter of accuracy. So it's a little bit less accurate than the RTK. But what are the advantages of that? So in this case, you have a continental coverage. It means that going from one, let's say, city to city, of course, is not a problem at all, but also moving between different countries, completely fine. And you're going to have the variation in case of delivery of the service. It comes with a really low bandwidth requirement. And also in case of the cost, it's really much more affordable than network RTK. And we can call it that it's the best price performance for many of the, let's say, emerging type of application also. And the PPP is a little bit more challenging, but of course it has a global, let's say, coverage, but it comes with a lot of proprietary type of format, which you have to use a specific type of receiver and so on. It's the best in the coverage, but also it has a really high price and challenges in the hardware. So if you want to kind of map what we talked about right now, if you mention that if you want to have centimeter level of accuracy, half a meter to few centimeter, and you want to have, let's say, really low OPEX, meaning really low ongoing cost, the PPP-RTK solution with the dual band is going to be an amazing solution for you. If you cannot sacrifice centimeters, 3 to 6 centimeter, you want to come less than 3 centimeter, then you need to go to network RTK type of application. Of course, with all the other restriction that it has, you have to consider so many different aspects about the coverage and so on. But for many of the emerging type of application, PPP-RTK is an amazing solution. So, and that's something that we can really see that the advantages of that in different colors. If you're a mass market type of application and you want to, let's say, provide your product into the market, don't want to limit your sales area, this is an option which is providing a lot of good, let's say, flexibility for you. But it's not only about the service, it's not only about the data, but it's stepping beyond that, as mentioned. So one of the things is actually the overhead, the costs that the data usage of the service is also bringing for you. It's a matter of how you want to bring one new device into your system, how you want to add it into the, let's say, subscription model, and also about performance of coverage, performance and coverage, we talked about it. That's also really important. You don't want to limit your sales market. If you want to have more detailed comparison, specifically also about, let's say, data consumption, you can see that when you're going to use network RTK, you need, if you're going to use 4 constellation, you need around 6 kilobit per second as a bandwidth requirement. Exactly the same thing from Point Perfect, our PTP-RTK service in the continental form. I don't know why this word continental is missing right now in this slide, but the first one here is the continental, which is 2.5 kilobit per second, which is almost 3 times less than, let's say, network RTK. And we have another, we introduced another, let's say, distribution model, which is localized. And in that case, the amount of the required bandwidth is around 0.5 kilobit per second, less than 15 times. That's amazing. And if we want to put that into some slide, we will see that here, that it's a huge amount of the data is different between them. Just an example, one application which is providing data usage of the 1 month for 24/7 usage. See that that's a huge amount of, let's say, difference in case of the data consumption. And if you put it into the cost, imagine that you have a 2,000 unit in the field, and each of them, they are working 5 hours. 7 days per week, 7 months per year. It's a seasonal application. And it's a completely realistic scenario, only for the data cost, not for the services cost. You're going to have a big difference. So if you're using a network RTK with 6 kilobits per second, you have to pay something around $113,000. Same usage, in case of the localized point perfect, you need to pay just $6,000. So that's a huge cost saving, more than 95%, which is also, if you don't think about it at the beginning, it's going to add a lot of, let's say, data cost, a lot of additional costs on top of your product. Another one, which is really important, we talked about it, is actually about the coverage. The coverage that we are providing with our point perfect is a continental, as mentioned. So we're covering fully the whole Europe, contiguous US, Canada, Brazil, South Korea, Australia, and also expansion is part of the daily life for us. Let us know if there are some other region that you are interested in that. We are always happy to hear from our customer needs, and of course we are also considering that. And keep that in mind when you're using network RTK. Sometimes even if there is a network RTK which is covering one whole country, they have a different mount point. So when you're moving from one state to another state, one city to another city, you have to change the mount point. And imagine that your application has to have this, let's say, intelligence inside to all the time changing this mount point. You don't want to deal with that. So in our case, for example, for whole continent, you can just get use of one single mount point, one single, let's say, point to get all the data. And in our case, you're just broadcasting everything. That's also really easy to implement it. And that was the way that it helped 01 Lab. So they got, let's say, a solution which is working out of the box together with the F9 and also Point Perfect. The flexibility in case of the pricing and also the financial model of the Point Perfect was kind of a trigger for them to bring this type of technology into the market. Another one, we can mention the company Winzy in US. They had also the challenges in case of finding the proper solution for their platform, which is reliable, secure, and accurate. And also with the same type of, let's say, setup, and also in case of, let's say, using different type of sensor, they achieve the goal that they have in the project. And as mentioned before, it's not only about data service, it's also you have to consider a lot of things when you want to have high precision positioning application. One of them is that, for example, we're providing our point perfect in different medium. One of the model is to receive that via the internet. You can, a lot of applications, they're getting that via the cellular. And the other method is L-band satellite, which they are geostationary satellite. In case of, let's say, IP, you might get, okay, I have a IoT type of application. I will get an LTE modem. I will put it bandwidth-wise. That's completely fitting, no problem. But you have to keep that in mind when you are using LTE type of technology. Let's say, in general, LTE, they don't like, and specifically MNOs, they don't like when you're doing something like streaming. And the correction service is a little bit like streaming. So the messages, in case of the RTK, is 1 hertz. In case of the point perfect, for example, you're sending every 5 seconds and every 30 seconds different type of packages. And it's a little bit like streaming. So you're hitting the alert limit of the MNOs. In that case, you're getting degraded in case of the delivery. So it means that your latency of the messages is increasing. And increasing of the latency for the, let's say, RTK messages means that your application is not going to use the corrections that you are providing for that. So one of the pro tips that we can have here is actually see a lot of benefit of getting benefit of the Cat1bis technology, which has the same price like LTE, but the performance it's using the Cat1 type of network, which is much more efficient, much more widespread, and also you're not going to have any problem with the latency in that case. And also, if you remember, just in the previous slide, I mentioned L-band delivery. So that's also another way. So you might think that, oh, that's amazing. So I don't need the cellular. I can use the direct satellite link to download my corrections, and that's fantastic. But you have to consider that each application might get benefit of different type of the delivery. So in case of the L-band, for agricultural type of application, UAV type of application is amazing, but not for every application. And also considering where your application is going to land, where your device is going to land, what is the operating environment. So one of the things which can affect is actually the shadowing effect. Considering the fact that L-band satellite is a geostationary satellite sitting on the horizon, 36,000 kilometers above the Earth. And when you're close to the equator, that's fantastic because the satellite is exactly above your head. So in that case, you can really get benefit of L-band delivery. But if you come to Sweden, if you go to higher latitude, in that case, any side of any shadow from the southern part, it might block, let's say, the L-band. That's a technology. So it's not about our service, someone else's service. It's just a matter of the technology of the L-band. So you need to consider that and take the right, let's say, services delivery for your specific application. And that's a point that we would be happy to help you and your team to select the right GNSS device, to select the right services, and also correct other components which it might affect, let's say, to your application at the end. You might also be in the middle of this procedure. I don't know, but I can guess so. A lot of you, you are implementing this type of technology. Another, let's say, quick tip that we can give to you is about you might take some of them and try to just mix and match them, try to test them. And at the end, you will get some result like this. So you use the same antenna, same place, two different, let's say, GNSS receiver, and you feed them with the two different correction services. But then you will see, oh, there's a big difference of 80 centimeter, one meter between observation of two GNSS receiver, which actually getting the same feed from the same antenna. Keep that in mind that if you're using two different correction services, each of them, they might use different type of coordination system. So the reference datum is really important also to consider that inside of your application. That's also another aspect of those challenges. So there's a lot of fine tuning inside of it. And that's the point that you're saying, as soon as possible, if you get in touch with us, we would be glad to support you. We talked about many different topics, but another really important one is actually the antenna. I bring an example from one of the customers that I had the chance to work with them. We went through a lot of up and down with this customer. We went through a lot of challenges together. And then we got some results from the customers, which actually this table at the back. So you see there are some highlights. And you see that all the L2 signals, it has a really, really, really low signal to noise ratio. It means that something is really kind of disturbing the L2 signals in all of the observation. And then you see that when you look at the RF spectrum, sometimes you see, oh, there is a peak inside of that, which is exactly falling into the same frequency. And that's a matter of interferences in case of the antenna. So keep that in mind. If you have a best GNSS receiver, best correction service, even the best antenna, but if you put the antenna in a bad place, if you're not using proper, let's say, isolation for your antenna, it might ruin everything. And this is something that also as a service we're providing to have a kind of design review for our customers. And also you can get help from the antenna manufacturers that they can be extremely efficient in this specific case. So just as a quick wrap up, you see that from the u-blox, which actually are DNAs in case of the GNSS from the first day of the companies. We're trying to provide this type of high precision solution. And together with the Collian, we try to make it even easier for you and provide all of them from one hand together with best antenna that you can get with a lot of expertise. So I will give the hand to Joe, and we will hear the rest of the story from the Joe. Joe, the floor is yours.
Thank you, Armin. Indeed, the antenna is one of the most important components to consider, as it is the first component to receive signals from space and also the first line of defense from interference. So we can ask ourselves, why do GNSS antennas matter? The answer lies in the way GNSS works. For three-dimensional positioning, an antenna needs to track at least 4 satellites. These satellites, being in medium Earth orbit, are around 20,000 kilometers away from the surface of the Earth. And for reference, the diameter of our planet is just shy of 13,000 kilometers. So while several dozens of satellites broadcast from several different constellations, the signals arriving on ground level are incredibly weak. The power levels are 1/10 of a millionth of a billionth of a watt. That's how weak. So as the antenna is the first component to receive these signals, it must be chosen very carefully, leading us to our pro tip. Precise positioning requires a high-performing antenna and careful system integration. So, Tally and GNSS, we were all about antennas. It started with a simple passive antenna, and from there, it was apparent that interference and cable losses between the antenna and the low noise amplifier, or LNA, proved troublesome. Therefore, it was advantageous to bring the low noise amplifier into the antenna, thus birthing active antennas. The next logical step, as capable receivers such as the u-blox receiver became more and more compact, was to integrate the receiver into the antenna, which we did through our partnership with u-blox. That way, the systematic design issues were minimized, giving system developers an expert integration with a high-performing and reliable GNSS antenna and front end. The smart antenna, as we call it, becomes a plug-and-play solution right out of the box. The goal is that our customers would get a validated GNSS performance so they can focus on their core business. No reason to worry about compatibility, signal coverage, filtering, etc. This solution boasts numerous features, as we can see in the following graphic. Our flagship smart antenna, the TW5390, is rich with features. Along with our state-of-the-art and proven patch antenna, the TW3972, we also include our extended filtering front-end technology, or XF, and an expert integration of 2 u-blox receivers, the ZF9R, with the integrated inertial measurement unit, or IMU, which is required for untethered dead reckoning, and the NEO D9S for L-band reception. This is all within our standard antenna form factor. These features enable an end user to achieve centimeter level precision out of the box, and thanks to point perfect over L-band, operate in remote geographies. We will review how this antenna performs over several case studies showing the functionality of the integration in 4 different modes. The first study comes from our own internal testing to evaluate how well the IMU was able to perform in an urban canyon setting. In an urban canyon, multipath interference causes the degradation of GNSS performance, where non-GNSS based augmentation is helpful in mitigating those effects. 2 antennas were tested, both single band, one standalone, and another enhanced with untethered dead reckoning, or UDR. The antennas were mounted to a truck and driven through downtown Montreal. The difference between the 2 antennas was night and day. To the left, you see how poor the GNSS was able to track over many passes around the block, where to the right, you see the line sort of snap to the road. This test was conducted for the city of Montreal, who uses these antennas on their snowplows. The snow and ice can pose a lot of dangers to pedestrians in Canada, and the city required a technology that can provide reliable evidence that the vehicle plowed the sidewalks and streets. Obviously, this has many benefits in protecting both citizens and the city alike. Accuracy here was key, and the IMU proved invaluable in the study and this application. In this study, an IMU test was conducted with the TW5390 near our office. Complete GNSS obstruction can often be a reality in many applications, such as traveling under bridges, underpasses, going through tunnels, and going into parkades. Having the IMU augmentation helps to fill the gaps during these events. This test was done to demonstrate the effectiveness of the F9 u-blox F9R's internal IMU in a car park located underneath a multi-story hotel. The 5390 was again mounted on a vehicle and driven around to calibrate the IMU. Upon calibration and GNSS fix, it was then driven into the parkade where several turns were made as shown in the images. After 3 minutes, it was driven out of the parkade. And while it is difficult to see, there is a slight correction upon the rather quick reacquisition of the GNSS fix, showing just a bit of IMU drift. This was actually quite an impressive result. Now, looking at a customer case study. This customer was using cameras and GNSS for Geographical Information Systems, or GIS mapping. Initially, the customer was using a standard RF antenna from us and was running into a lot of system integration issues due to the noise from the camera degrading their GNSS receiver module performance. On a site visit, our director of systems had brought with him a TW5390 and plugged it into their system. As soon as he plugged it in, all of the issues went away, demonstrating that the benefits of an all-in-one integration of the smart antenna. Here, the protected RF chain is more resilient to system noise than a standard RF antenna. Also, in addition to that, you get the benefit of a smaller system footprint. You no longer need the receiver to be outside of the antenna. Position Partners, now Aptella, is an extremely experienced GNSS services company operating an RTK cores network throughout the entirety of continental Australia. This next case study has one of their engineers test our antenna in both static and rover scenarios. They compared the performance of the smart antenna with a traditional integration. So I was just in Australia last month and had the pleasure of receiving their feedback firsthand. They were quite happy with our full integrated solution, how compact it was, and how it was comparable with the standard solution. In particular, the IMU was very helpful when encountering GNSS obstructed environments, such as through an underpass or next to tall buildings. They had the opportunity to demonstrate to a top-tier Australian client the capabilities of point-perfect PPP-RTK services from u-blox using our smart antenna. The point was to demonstrate the ease of deployment and the quality of this product being in a lower-tiered price point. This shows a whole new paradigm of performance versus cost. The last case study I want to show you today is from Indro Robotics, where 2 of our smart antennas were used in tandem for precise heading. In this case, one antenna was set to be the moving base and another to be the rover, where the antennas were spaced at least 30 centimeters apart. You can see in these images that in the robots shown, it looks like they're installed about 50 centimeters apart to increase the heading position. The solution was demonstrated in our presence and was shown to be quite agile in maneuvering around obstacles. This demonstrates the capabilities of the antennas in a precise heading configuration. With that, it proved that with an out-of-the-box setup such as this one, the limitations on where rovers can operate is greatly reduced. Not only are they able to achieve centimeter-level precision in position, but also in heading as well, precise heading. All these case studies to say that our plug-and-play integration of a precision antenna with the u-blox receivers allows our clients to operate over 4 software driver modes: standalone, precise heading, PPP RTK, for example, with point perfect over IP or over the L-band satellites, and RTK. Our SDK package, along with our True Precision software, enables quick access to all these features, including the point perfect service. Also, we were working together with different frameworks such as ROS2, RGPilot, and PIX4 Autopilot. So call up a routine, set the receiver to a particular mode, and you're off to the races. Back to you, Armin.
Many thanks, Joe. That's amazing. So as a kind of a wrap up for the whole presentation, we see that the need of the high precision positioning with the RTK is getting more and more, and also there's a lot of application which is necessary to have this technology. And we try to pave as much as possible this road and make it easier for you and your team to make it more accessible, affordable, and also easy to integrate, and bringing this type of technology into the mass market. We are doing different type of case studies in that case, and which we see a lot of, let's say, valuable options from different type of customers. So feel free to get in touch with us as soon as possible. That would be fantastic, because then we can consider all the elements together from through the website of the u-blox or various channel. Also the support that we have the email here. We will be glad to help you in that case. Many thanks for that. And I think that's the last slide that we have. Holly, are we going to the Q&A?
Thank you, guys. Yes, at this time, we're going to jump into some questions that we've received during registration and a couple that we received during the presentation. Our first question says, in the case of Point Perfect, in what format is the service provided? Is that RTCM?
Oh, that's a really good question. That's really interesting. So whoever asked this question, thank you for that. And the Point Perfect, until now, it was based on an open industrial format with the name Spartan. And also through the, let's say, protocol, communication protocol of MQTT, we used to provide this service. Your question is right now leading me to mention that for the first time it's mentioned, it has not been public. That's the first time I'm announcing that here. So from now on, we are going to also provide Point Perfect, not only in case of the MQTT, but also with the NTRIP. So you can receive Spartan on NTRIP. And also in the near future, we are going to also have, let's say, RTCM on NTRIP. So you have a full flexibility in that case to receive the service based on the existing hardware that you have, the existing capability that you have. You can get benefit of the RTCM, get benefit of Spartan. Each of them has its own advantages. For example, in case of Spartan formats, data format, it's really the low bandwidth option is coming from with this option. And also we talked about Point Perfect localized, and also the capability of really being extremely low bandwidth. This is thanks to the MQTT, which this kind of options is available. But if you have some device in the field, which they have NTRIP clients on board, you're getting use of different corrections. Right now, you want to, let's say, unify that and get a benefit of the Point Perfect. You can use either, if you have F9, you can get use of the NTRIP and Spartan, or if you have third-party services, third-party hardwares, you can use NTRIP and RTCM. Holly, back to you. Next question.
Thank you. Okay, any suggestions on how to use the dense tree canopy method?
That's also a good question. So when you have an environment which has a lot of obstruction in case of signal reception, our recommendation is to use dead reckoning functionality inside of your hardware. So that's something which is, let's say, really helping you in case of keeping, let's say, the reliability of the solution, keeping your precision until you're going to have the, let's say, open sky view again. Joseph, what do you think?
Yeah, that's so on the antenna side, you could also do something by making the antenna or choosing an antenna technology that's a bit more sensitive to the signals. Sure. So while you have the obstruction, maybe have an antenna that's a bit higher gain, maybe a higher gain at lower elevations. This is assuming like it's maybe a perfect flat environment and it's just you're in a forested area. And trying different antenna technologies would help just see if you receive the signals, even though they're a little weaker, then having a more sensitive antenna would help try to capture those signals.
Exactly, and also, for example, getting benefit of different type of signals in this type of disturbed environment and high multipath is also really important. For example, getting benefit of helical antenna or different type, that's also really important.
Back to you, Haley.
Thank you, guys. Does the reducing of the cost impact the accuracy of GNSS measurements? And if yes, to what extent?
Okay, I think partially we answered that through the presentation. There are different type of receivers which has, let's say, higher specification. And also we talked about the services that RTK, network RTK is around 1 to 3 centimeter theoretically. And point perfect or PPP RTK type of services, they are around 3 to 6 centimeter. These are what you can have it on the paper, but that's the way that you can, let's say, as a rule of thumb, you can really go through that with this type of, let's say, definition. And also it's a matter of the single frequency, dual frequency, or tri-band. Of course, there is a huge difference between the single and dual band. If you're thinking about, as mentioned before, few decimeter, few centimeter type of application, for sure going for dual band is the recommended solution, minimum. And also getting benefit of PPP RTK, or if you cannot use even few centimeter, but you're flexible in case of the coverage, so your application is really regional, you can get benefit of the base station or available network RTK. But as an OEM, that might be a little bit challenging.
Awesome. I want to add to that, on the antenna side, there's always going to be the cost reduction there as well. So while you don't need to use like the absolute best patch antenna, the absolute best, there are other antennas that use maybe the same type of technology of like, for example, our TW3972 with the Accutenna, we got the dual feed and really good axial ratio. So it captures, it's as sensitive as a patch antenna can be. So to allow you to get to centimeter level precision, but it's a little cheaper because it would be a different integration of it, maybe a smaller form factor like the TW8889, which is a dual band miniaturized version of the TW3972. Not to sound so much like a salesperson, but just there's always going to be that tiered level of the same technology. And Tallysman's actually, Calian is really proud to offer a wide variety of antennas that would fit in many different price categories.
Thank you both. How can the RTK correction networks migrate to 5G in rural agricultural areas when major telecom carriers are resistant to 5G deployment?
So that's a good question. In case of the 5G, of course, in the 5G implementation, some cases also they're considering different type of corrections inside of that network, but actually you don't need that if you're targeting to have that in a rural network. So as mentioned, in case of, for example, Point Perfect, we have the delivery via the L-band satellite. So you're absolutely don't need to have the IP connection while you're doing your observation. In our case, you just need the IP, just need the connection to the internet every 50 days because the service is actually encrypted, so you just need to have the keys. Of course, keys can be side-loaded. It can be also provide, for example, as an I imagine your application is something like agricultural application. So it's a tractor which is going to the field, but it's coming to the base. And most probably in the base, you have cellular coverage or you have internet access. So one time your system can ping, let's say, the topic, and also can subscribe and get the keys. And that's the way that a lot of our customers solve their problem if they have application in the rural area, so they can get benefit of the L-band. And keep that in mind also, having a really low bandwidth requirements in case of the Point Perfect. This is also really helping a lot of customers, even if you have only 2G or if you have a really disturbed network, you can really rely on what we're providing in the Point Perfect. And also another benefit is that you can, the frequency of the message is much less. So you can rely, of course, in the last epoch of the correction that you received for a while. There's a lot of technical detail into that. If you want to get in touch with us, we can have a discussion more about it.
Thanks, Armin. We have a question that says, I am interested in achieving sub 10 centimeters X, Y, and Z surveys that can be achieved globally, or at least in North America and Japan. I've been using Trimble RTX corrections, but wanted to know if there's a single more cost-effective RTK solution at that described accuracy and availability.
Right. So I think we mentioned the solution that we're providing in that case. So it is in many cases, if you compare the expectations and the specification of the different services, you can find out which service is really compatible with your type of application. And I can imagine that in case of the point perfect, it's really can get a benefit in your application. You mentioned that it needs to be global application, so what you're providing is continental. And in the global case, Holly, did they mention which region they are interested in that? So maybe I missed that.
They did mention at least in North America.
They didn't mention that.
Japan,
no, they mentioned only North America. Yeah, so North America is actually fully covered by Point Perfect. So feel free to try that.
On the antenna side, I would say what limits you in terms of the precision you're going to be getting would be the really the face center variation of the antenna. And in a way, you could sort of think of it as the sharpness of a lens if you're thinking about a camera system. So the sharper the lens, the more clear the image. So the face center of the antenna is like the smaller it is, the variation. If that's very small, then you can get to that level of precision theoretically. So everything else has to work together to provide that level of precision. But for 10 centimeters, really, any technology would be able to achieve that. Most antennas are more or less precise in the Z axis than in the XY. So it says sub 10 centimeters in both XY and in Z. So the Z would be maybe on the limit with the patch antenna, but with an integration of maybe a more precise antenna, that would be possible.
Right now I see the question inside of the platform. So just one more comment. Of course, North America, Europe, both of them are fully covered with the Point Perfect, and as also mentioned by Joe, Z, let's say accuracy is usually you can consider that it's 2 times the accuracy, the horizontal accuracy. So that is a little bit more challenging. So you need to really consider a proper system which you can achieve this accuracy in your application. Alan?
We'll do one final question now before wrapping up today's event. I want to set baselines precisely within 3/8 of an inch in Mekelle, Ethiopia. How would that be possible?
Joe, do you want to comment there?
I'll start with that, yeah. So with that's about 3/8 of an inch is about maybe just under a centimeter precision. So with that, it will be difficult through PPP RTK from our presentation. It seems like the best option would be to use an RTK system. And if you want to get down to the sub-centimeter level, then that would be something that's maybe not a patch. Patch, you're on the limit, but so with something like an actual geodetic antenna. So on the Callion side, that's a Veriphase or a Verichoke, sort of a higher end antenna with a phase center variation of millimeter level. So somewhere around 1 to 2, 3, 5 millimeters, which would allow you to get down to that level of precision. On Armin, is this possible with the u-blox to get down to that much?
Well, with the hardware, yes, of course. You can get benefit of the ZF9 into that case. We don't have, unfortunately, coverage in Ethiopia. In case of the Point Perfect, you're not, unfortunately, covering Africa for the time being, of course, although might be in the radar for the future. But what you can get benefit is actually base station. So you can use one GNSS as a base station locally and one, let's say, as the rover. You mentioned that you want to set a baseline. Needs a little bit more, let's say, explanation about that, what exactly you want to do with your application, but definitely getting benefit of the base station rover setup that can help you in that case.
Cool.
Ollie, back to you.
Thank you both. Thank you for attending the practical tips for reducing costs and complexity of high precision RTK solutions, brought to you by GPS World Magazine and our sponsor of the event, u-blox. A recording of this webinar and other upcoming webinars from GPS World will be posted to gpsworld.com/webinars. Thank you all for attending, and we hope you'll join us again soon for another great webinar.